In this particular video, we're going to discuss applications that have rational equations. Remember, rational equations are those that have the denominators, okay? So in this particular example, Jesse takes a 3-day kayak trip and travels 72 kilometers south from Everglades City to a camp area in Everglades National Park. The trip to the camp area with a 2 kilometer per hour current takes 9 hours less time than the return trip against the current. Find the speed that Jesse travels in still water. What we have to remember is that our distance is equal to rate times time, or in our case, time is equal to distance divided by rate. And it's going to help us to know this particular thing. So we know that he had a trip to the camp, and that was with the current. So I'm going to put here with current. We also know he had a return trip that was against the current. Okay. So now then his distance, we're going to look at his distance, his rate, and his time. Okay, his distance, both directions, is actually the 72 kilometers. And I'm going to put up here in kilometers. And then I'm going to put his rate is kilometers per hour. So his time is in hours. So now then, with the current, he has a 2 kilometer per mile current. So when you're traveling with the current, you have your rate plus the rate of the current helping you flow, okay? So think about when you're jogging, if you're jogging with the wind, you actually get that little bit of a push, so your rate increases. Now, whenever you're going against the current or against the wind, that rate decreases, and it's still the 2 kilometers per hour here. Now notice up here I said time is equal to distance divided by rate, so it is my distance, 72, divided by my x plus 2, and my 72 divided by my x minus 2. And the reason I did this is because we know something about the time. His trip to the camp was 9 hours less than his return trip. So if we look at it as his trip to the camp, that takes 9 hours less than his return trip. So let me erase this and say his return trip. And we want this all to be in time because of this 9 right here. Okay, so his trip to the camp was 72 over an x plus 2. His return trip was 72 kilometers over an x minus 2. And we're going to subtract 9 from that because it's this return trip minus 9 hours gives me his trip 2. And think about it, his return trip takes longer. So if we take off that extra 9 hours, we get his trip to the camp. So now we have a rational equation set up. And so I'm going to find my least common denominator. So my LCD is going to be an x plus 2 times an x minus 2. Remember, I have to set that where it's not equal to 0. because of those restrictions. So x plus 2 cannot equal 0, and x minus 2 cannot equal 0. So x cannot be a negative 2, and x cannot be a positive 2. And remember what we're talking about. X is our rate. So x always is going to be positive. So this one doesn't even matter anyway. But we have to make sure that we look at those restrictions and pay attention. So I'm going to take my LCD, x plus 2 times an x minus 2, and I'm going to multiply it by each of my terms. So 72 over x plus 2 is equal to my common denominator, x plus 2, x minus 2, times that 72 over x minus 2. I'm going to go ahead and put minus 9 and then put my x plus 2, x minus 2 here. You really have to be careful with these negative signs, okay? So whenever I look, notice that this x plus 2 and this x plus 2 cancel out, leaving me with an x minus 2 times a 72. That's times a 72 is equal to, this cancels with this, leaving me with an x plus 2 times a 72 minus 9 times this thing, x plus 2, x minus 2. Okay, so 72 distributed in here gives me 72x minus 72 times 2 is a 144. 72 times x gives me 72x plus 72 times 2 gives me a 144. Minus 9, I'm going to FOIL these, so that gives me an x squared minus 2x plus 2x minus 4, because I took x times a negative 2x, or negative 2, a 2 times an x, and a 2 times a negative 2, okay? So on the left-hand side of the equation, there's not much for me to do. On this right-hand side, I'm going to keep my first two terms for the time being. Notice this negative 2 and positive 2, those cancel each other out, okay? Leaving me with a negative 9 times x squared, so that's a negative 9x squared. Negative 9 times negative 4 gives me a positive 36. So I have an x squared, so I've got to do some relocating. But if you notice, if I subtract 72x from both sides, those go away. And so I'm going to subtract the 144 from both sides. These go away. That's going to leave me with a negative 288 is equal to a negative 9x squared plus 36. So I will subtract the 36 from both sides. That will leave me with a negative 324 is equal to a negative 9x squared. I want to get this x squared by itself, so I'm actually going to divide both sides by a negative 9. When I do that, these cancel. Negative divided by negative becomes positive, so I'm going to get an x squared is now equal to a 36, because 324 divided by 9 gives me 36. That looks more like something we can figure out easily. So I'm going to take the square root of both sides. Remember, positive or negative square root. So that's going to leave me with an x is equal to a positive or negative 6. Now recall what x was. X was Jesse's rate. He can't go negative 6 miles per hour. So my only solution is 6. So Jesse travels 6 kilometers per hour in still water. And remember that anytime you're working with application problems, your final answer is always in a complete sentence. So you're going to have to really practice these with the rational equations and the applications. So practice some and then let me know if you have questions.